So I hope you've been thinking really hard about this situation because as teachers, we don't just tell, and wait for our students to regurgitate all the things that we told them. What we ask our students to do is to think and to reason and to make sense. And so if you were in the classroom situation and you asked students, or like in my case, I've asked teachers, I've asked college students, I've asked elementary students, I've asked parents, what is the perimeter of this purple rectangle? What I want to get at as a teacher is I want to assess that person, let's say a student's understanding of the idea of perimeter. Now, based on the response, I can better understand their thinking. So, put your teacher hat on now for a minute. You're in the classroom, you're working with students, and you want to assess. Now, I don't mean in a formal way, but just in a moment of learning. Say on a particular day you've been working with perimeter, you want to assess to see if they understand. And so you give them a question like this that's intended to pull out important ideas, and you get these three responses. The first response that we often get in this situation is that the perimeter is 22. Now here's what would happen. I would say, student A, show me how you got 22. And here's what student A would do. They would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. The perimeter of this purple rectangle is 22 because perimeter is the distance around. And so if I count the border around the purple rectangle, I get 22. Now notice 22 is just left empty. 22 what? So then I would try to push. Student A, you say the answer is 22. 22 what? Like, what are you counting? Well, clearly what they're counting are these orange squares. What a student is, even if not intentionally, what a student is saying is that the perimeter of this purple rectangle is the 22 orange squares that surround the rectangle. Now we know that perimeter is not about counting squares. A perimeter is about a length, a one-dimensional length. These squares are two-dimensional. That's not perimeter. Perimeter is a one-dimensional length. Now there may be another question where counting those orange squares would be appropriate, but not in the question of what is the perimeter of the purple rectangle. Now, please don't think, well, that's a tricky question. That's not fair. No, it's not. It's not a question that you're going to give a grade on. It's a question that you're going to ask to assess to see if students really understand perimeter. And since perimeter is a one-dimensional length, the student who's counting squares needs to be fine-tuned in their thinking. All right, let me erase that because I want to share with you what the other students think. Sometimes students get an answer of 14. And so if a student got an answer of 14, I would ask them, what are you counting to get 14? Here's what they would do. They would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. They would count because they're thinking perimeter is some kind of a distance around. So I'm just going to count around the purple rectangle and get 14. But again, 14 what? Well, what we're counting here is 14 purple squares. Kind of go around the purple rectangle. But that's not what perimeter is either. Perimeter is not about a two-dimensional border. Perimeter is about a one-dimensional length. And so this would be important for us to be aware of as teachers if students are counting squares versus counting what they should be counting. Now, perimeter. To really get at perimeter, what we should be counting is one-dimensional things. So here's what you should be counting. 1. Here, let me highlight it. You should be counting 1. You can't see that, can you? Let me try a different color. You should be counting 1 length, 2 lengths, 3, 4, 5, 6. And then coming down 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. The perimeter of this purple rectangle is 18. 18 what? Exactly, we need to be clear. It's 18 of these lengths. There's 18 side lengths or square side lengths that represent the border of the purple rectangle. That's what we should be counting as one-dimensional lengths. Now, if these were, let's just say we got a ruler out and we laid a ruler down on top of this thing. Maybe those lengths are, oh, I can't do it now. I can't spin it. Well, I'll do that later. But the point is this. If you laid a ruler down here, and let's say each of these were 1 inch, you would say 1 inch, 2 inches, 3, 4, 5, 6, 7, 8, 9, 10, 18 inches. You could say that. But the point is you're counting one-dimensional lengths, not two-dimensional squares when you think about perimeter.